So why are we interested in looking at how to generate random values using quick check? Well, the main reason is that we need this whenever we generate a new type. Whenever we create a new type, if we're going to test functions over that type, then we need to tell quick check how to generate random values of that type. And that's because quick check has no way a priori of knowing how to generate random values of a type it's never seen before. So we'll take the example of the data types from Lab 2 to show how we can create generators for this data type. Now in the lab you were given these generators in some library code so that you didn't have to think about it. You could just run quick check on your properties. But behind the scenes, we'll see what was behind the scenes here and now. Okay, so the first thing we're going to have to do, if we're going to make something into something that can be tested randomly, is to make this type a member of the class big arbitrary. So the way we're going to do that is making a new instance of the new class arbitrary, namely suit. So how do we do that? Well, there's one function that we have to define. The minimum definition is to define arbitrary. And arbitrary should be a random value, is a generator for values of type suit. So this is a very simple data type. It's the data type of, it's the enumeration type for the 4 different suits. So the way that we can generate that is to use elements. And we start and we can just list all the elements of this type. Now, let me just note that actually we could save us a couple of characters, not many characters, but if we add this to the enum class by deriving enum as well, then we can actually use this notation from spades to clubs, where spades is the first element of the type and clubs is the last. So this is the list of all of the elements of this type, and the arbitrary then is defined just to choose one of those 4 at random. Okay, so now we're going to move on to looking at how to generate random ranks. Now the rank type is a little bit more complicated than the suit type because it has one of the constructors which is a function. It takes an int in order to become a rank. So numeric is a constructor function with an int as an argument. So this example makes it a little bit more complicated. So it gives us a chance to illustrate use of some of the other building blocks from the quick check library. So I'm going to break this down into generators for 2 different things. I'm going to look at a generator for numeric cards and a generator for royal cards. So the numeric cards are these ones and these are the royal cards. So I'm going to split it into 2 generators, and then I'm going to define arbitrary by combining those 2 generators. So let's start with the first one, which was a numeric card. And here I'm going to use a do block, at least initially. And the reason I'm going to use a do block is because every numeric card has an integer value, and that integer value is in the range from 2 to 10. So I have a generator that I can use to generate values in a given range. It's the choose generator. So I'm going to choose something in the range 2 to 10 as my first step of my generation instruction. And I'm going to call that numeric value n. So n is the value in the range 2 to 10. And now what I want to do is I want to return the numeric card containing the value n. So I'm going to return a numeric card containing the value n. And that's my generator. And those of you who were observant in the from what we talked about earlier, there is our special apply operation. It's actually sometimes referred to as fmap. So this is the fmap operation. We could have written numeric applied to the result of choose something in the range 2 to 10. So this would be an alternative way of writing this do block if you want to get a little bit more slick with your operations. What about the royal cards? A random royal card. Well, this is a much easier case. This corresponds to the case we had above. We're not a member of the enum class here, and that's not so easy to do here when we have this more compound data type. So we can simply list all of the values of the type one by one. So we just need to list them all: Jack, Queen, King, and Ace. And when we've done that, then our generator can be defined by taking elements of that list. So we have two generators for random ranks, and now we want to combine them together to create a generator for arbitrary ranks. So we want to make an instance of arbitrary where we use one of the two generators that we have, random numeric and random royal. So what that means now is that we have instructed QuickCheck on how to generate random values of type rank, and that's great. Now remember that we had a data type invariant defined for our ranks. All ranks should always have a proper value, which means that the value inside, if we have a numeric card, should be between 2 and 10. And we can actually run this now because we know how to have a generator. So what happens when we're running QuickCheck on prop rank, our data type invariant, is what we're doing is we're actually checking that our random generator has the property that we want it to have. And indeed it does. So that's good news. But actually, this is a good point to show you some ways that we can inspect what's going on inside a generator. So one way is to use verbose check. We've used that quite a few times. But another way is to use some more functions from the QuickCheck library. And I'm going to show you one quickly here. I'm going to define a new rank function, rank prime, for some rank. And I'm going to define it by modifying prop rank of R using a QuickCheck property modifier. And what it is just a way of collecting some data about the random ranks that are generated. And I'm going to do that by using a function called classify. And for every rank R, which is less than Jack, I'm going to classify that as numeric. So I'm going to what I'm doing here is labeling. I'm labeling every rank that's generated where the rank is smaller than Jack, in other words, every numeric card. I'm going to label that numeric. And now when QuickCheck runs this property, it will do the same as it did before, but it will add some extra data, and I've just typed the same thing twice. So, okay, so there's my rank prime. So let's reload that and go about actually running it. So this will do the same tests as before, but now it will also collect a bit of data along the way. And what it shows us is that it passed the test just as it did before, and that 51% of our tests were numeric, cards were numeric, rather our ranks were numeric. And that's kind of what we would expect. We would expect around 50% to be numeric, about half of our cards to be numeric. And that's because we're randomly choosing either a numeric card generator, rank generator, or a royal rank generator. And that's sort of half the time it will choose one, half the time it will choose the other. But actually that's maybe not a great distribution for a hand of cards. I mean, it probably doesn't matter too much. But actually we can do better. We can control the distribution. Instead of using one of, we can use a fancier function called frequency. So frequency, instead of taking a list of generators, takes a list of generators together with a weight to give you an indication of the proportion of times it will use one as opposed to the other. And so what we're going to do is, with a ratio of 9 to 4, for every, we're going to choose a numeric card 9 times and a royal card 4 times. So this will give the proportions that the chance of choosing a numeric card will be 9/13, and the chance of a royal card will be 4/13. In other words, the cards will appear in the random testing in the same proportion as they appear in a deck of cards. So if I now reload that, I forgot to use frequency. So I'm going to use frequency instead of one of. And now if I rerun my test, now we see that a little bit more like we would expect, about 70% of the cards, in other words 9/13, how much is that? That's about just under 70%. So about 70% of the time we will get numeric cards. So frequency is the operation for controlling controlling that.